Hello dear student, welcome back to the series of database management system. Today we are going to see what is normalization. Normalization is the process of organizing the data in the database. Normalization is used to minimize the redundancy from a relation or set of relations. It is also used to eliminate the undesirable characteristics like insertion, update and deletion anomalies. Normalization divides the larger table into smaller table and link them using relationship. The normal form is used to reduce redundancy from the database table. So we have different forms of normalization. Our first normal form is 1NF, that is first normal form. A relation will be 1NF if it contains an atomic value. Atomic value means what? The one cell will contain only one value, no multiple values allowed. That is called atomic value. Okay, so this is the rule of 1NF. It states that an attribute of a table cannot hold multiple values. It must hold only single value attribute. First normal form disallows the multi-valued attribute, composite attribute and their combination. Okay, so composite attribute or multi-valued attributes are not allowed in 1NF. So that means only one cell will contain only one value. So if the person have two phone numbers, it is not allowed. Okay, in one cell you have to insert only one value. This is my first normal form. For example, we have relation students in table 1 is not in 1NF. Why? Because of multi-valued attribute. Okay. Student phone, it is decomposed into 1NF has been shown in table. So for example, we have table 1 and we are saying that it is not in 1NF. Why we are saying that? We have student 1 Ram who have two phone number. So that means what? Here the data is the cell contains multiple data into single cell, which is not allowed in 1NF, correct? So that means the data is not in 1NF. If you want to convert my data into 1NF, what you have to do? You have to write this data twice with first phone number and then with second phone number. Okay, so now my data is in 1NF, correct? All the fields, all the cells contain only one data, correct? So now my table is in 1NF. Okay, clear? Now next is second normal form 2NF. In 2NF, relation must be in 1NF. So first rule of 2NF is it should be in 1NF. That means the single cell should contain only one value. In second normal form, all non-key attributes are fully functionally dependent on primary key. Means what? In the second normal form, all non-key attributes. Non-key attributes means what? The attributes which uniquely identifies your table, correct? So all non-key attributes should be dependent on primary key. Okay? Let's assume a school can store the data of teacher and the subjects they teach. In a school, a teacher can teach more than one subject, correct? So here is a table, teacher ID, subject and teacher age. Okay? Now teacher ID is 25, 25, 47, 83, 83. In the given table, non-prime attributes, that is teacher age, is dependent on teacher ID, correct? Which is a proper subset of candidate key. That's why it violates the rule of 2NF, correct? To convert the given table into 2NF, we decompose it into two tables. Okay, now we'll write teacher ID and subject. Second table is teacher ID and teacher age. Okay, so that means my table will come into 2NF. Next is third normal form. A relation will be in 3NF if it is in 2NF and not contain any transitive partial dependency. Means what? A tends to B and B tends to C is not allowed in third normal form. 3NF is used to reduce the data duplication. It is also used to achieve the data integrity. if there is no transitive dependency for non-prime attributes, then the relation must be in third normal form. Okay, so non-prime attributes should not have transitive dependency. For example, we have a table employee ID, employee name, employee zip, employee state, and employee city. Here employee state and employee city depends on employee zip and employee zip depend on employee ID, correct? So that means the non-prime attributes state and city transitively depend on super key employee ID. It violates the rule of third normal form, correct? So that means city and states are dependent on zip and zip is dependent on employee ID, correct? So it is A tends to B and B tends to C, correct? So that means it is the transitivity, correct? So that means it is not in third normal form. Now to convert these into third normal form, what we have to do, we have to decompose our table and we'll write employee ID, employee name and zip, and then we'll take the second table where we will take employee zip, employee state and city. Okay, so that means employee zip is not dependent on employee ID, correct? Okay, so there is removal of transitivity rule. Okay, so now my relation is in third normal form. Next is primary key. It is the first key which is used to identify one and only one instance of an entity uniquely. An entity can contain multiple keys as we saw in person table. The key which is most suitable from those lists becomes primary key. In the employee table, ID can be primary key since it is unique for each employee. In the employee table, we can even select license number and passport number as primary key since they are also unique. For each entity, selection of primary key is based on requirement and developer, correct? So primary key is nothing but a key which is unique, which does not accept null value, correct? Next is foreign key. These we have already seen. Once again we'll revise. Foreign key are the column of table which is used to point to primary key of another table. In a company, every employee works in specific department. An employee and department are two different entities, correct? Two different tables. So we can't store the information of the department in the employee table. That's why we link these two tables through primary key of one table. We add the primary key of the department table, department ID, as a new attribute in the employee table. Now in the employee table, department ID is the foreign key and both the tables are relatable. So by using foreign key, we can connect two tables. Okay. Next key is super key. We can define a super key as a set of those keys that identify a row or a tuple uniquely. The word super denotes superiority of a key. Thus, a super key is the superset of key known as candidate key. The role of super key is simple to identify the tuple of the specified table in the database. It is the superset where the candidate key is a part of super key only. So all those attributes in a table that is capable of identifying the other attributes of table in a unique manner all are super key. For example, in employee table, employee number, passport ID, the registration number all are super keys which uniquely identifies your records. Next is candidate key. A candidate key is a part of a key known as super key, where the super key is superset of all those attributes that can uniquely identify a table. The role of candidate key is to identify a table, row or column uniquely. Also, the value of candidate key cannot be null. The description of candidate key is no redundant attribute and being a minimal representation of a tuple. So your candidate key is a subset of super key. Okay, clear? So super keys are all those keys which uniquely identifies your records. Okay, and the candidate key is the subset of the super key. Okay, that means the minimal key which is required to uniquely identify your table or records of your table is called as candidate key. Clear with all the keys: primary key, foreign key, candidate key, and the super